Good day class, welcome to this busy tutorial. Today we are talking about differentiations of vectors. In this topic we teach on usually three subtopics. Number one, gradient of a vector. Two, chord and divergence. Three, normal of a vector. And we have questions on these three subtopics. This question one. The question says, find the normal of a vector x, y cubed, z squared minus 4 at points -1, -1, and 2. So let's solve. So we have solution. Say the vector is that. Let's call it vector p. So vector p equals to x. Sorry, given, very important. Vector p equals to x, y cubed, z cubed minus 4. These are vector p. And points, the point is -1, -1, and 2. So you find the normal of the vector. And in the position of vectors, you find the normal. Formula for the normal vector, n bar equals to your vector operator times the vector itself. In this case, it's vector p. So times vector p. This is the formula for the normal vector. And what's the vector operator? Recall, vector operator is I plus J plus K. This is a vector operator. This is very important. This is very important in the position of vectors. This vector operator is very important. So normal vector is vector operator times vector that was given. So now, meaning we can say our normal vector now n equals to our vector operator, which is I plus J plus K times P. Putting this now, you can say normal vector equals to I this P will multiply the three of them. So I and P plus J P plus K P. What does this mean now? This means you differentiate this your function for this I part. For the I part, differentiate your function with respect to x. For the j part, differentiate your vector, with respect to y. And for the k part, we have gotten this formula, which is I partial with respect to x, p plus j partial with respect to y plus k partial with respect to z. This means for the I part, you differentiate your p with respect to x. For the j, differentiate your p, which is a vector, with respect to y. And for the k, differentiate your p, which is a vector, with respect to z. So now let's start. So we have gotten our n. This is, we just expand this bracket. This p multiplied everything inside this bracket. So now let's put our value of p. So we have n equals to I partial with respect to x. Our p is what? S y cubed z cubed minus 4 plus j partial with respect to y. Our p is what? X y cubed z cubed minus 4 plus k partial with respect to z. Our p x y cubed z cubed minus 4. Let me go over again. You said the formula for normal vector is vector operator, which is this is the vector operator times the vector which is given. And we took this vector as vector p. So vector operator times vector p. This is our vector operator times our vector p. But this p will multiply everything in the brackets. You open this bracket. That's why we got this I partial x p j. This p, open this bracket. And what is our p? This is our p. So we just substitute our value of p here. This is what we did. So now let's continue. n plus 2. This thing means for I, we differentiate this p or this vector with respect to x only. That is partial with respect to x. For this, we differentiate only x here. So now let's try it. For I, differentiate only x here. Differentiate x turn to 1. So x is gone. We have y cubed, z cubed. Differentiate 4, 0. Differentiate the constant 0. Bracket I plus. For j, we differentiate only y. So differentiating y here, this is y cubed. We differentiate y cubed, we have 3y squared. So meaning x, only y we're differentiating. Bracket 3y squared z cubed. 4 gone. J plus. This now meaning we differentiate only with respect to z. And differentiating z cubed is 3z squared. So we have x y cubed 3z squared cubed. So now n equals to y cubed z cubed I plus 3 s open this thing well. It will be 3 x y squared z cubed j plus 3 x y cubed z squared cubed. This is our final answer. But point was given. If there was no point given, this is our final answer. But they gave us points. So because point was given, our final answer now would be. Because they gave us points, our final answer now will add our points. From our point is minus 1, minus 1, minus 2. This is x, y, and z. So substitute the value of this into this equation. We have n equals to x is minus 1, so no x here. Y is minus 1. Minus 1 cubed is minus 1. Z is what? 2. Z cubed is what? 8. So times 8. I plus 3 times x is what? Minus 1. That is 3 bracket minus 1. Y squared. Y is what? Minus 1. Minus 1 squared is 1. So bracket 1. Z cubed. Z is 2. 2 cubed is 8. 8. So bracket j plus 3 times x is what? Minus 1. So that is 3 bracket minus 1. Y cubed. Y is minus 1. Minus 1 cubed is minus 1. So that is minus 1. Z squared. Z is 2. 2 squared is 4. Okay. So we have finally n, which is our final vector is minus 1 times 8. Minus 8i plus 3 times minus 1 times 1 times 8 will be minus 24j. So plus times minus minus this side come minus 24j. 3 times minus 1 times minus 1 times 4 will give us 3 minus 1 times minus 1 1. So 3 times 4 12 plus 12k. This is our final answer. Minus 8i minus 12j plus 12k. Now let's go back to the second question. So the second question says, for any scalar function f given, for any scalar function f x, y, z equals to f squared plus y squared plus z squared. Find the gradients. Gradient and normal is simply the same thing. You just do your vector operator, which is this. Don't forget the vector operator, don't forget, it's very important. I partial respect to x plus g partial respect to y plus k partial respect to z. So to solve for gradient and solve for normal is the same thing. So this is the assignment. Solve this gradient the same way we solve the number, but this one there is no point. Unlike the number, that point was given. This one there was no point given. to solve it and leave the answer. Post your answer in the comment section. So now let's go to the third one. Yes, gradient and normal is the same thing. Exam, we tell you gradients. It's the same working method of solving for normal. So don't confuse yourself. Gradient and normal is the same method of solving them. Now let's go to the curl and divergence. We have a question here. Given for any vector function, this, find the divergence and find the curl. So let's write the function, vector function v equals to x, y, I plus y, z, g plus z, x, k. This is the vector function. Except to find the divergence and the curl. Divergence is simply dot products, while curl is cross products. So I posted a video on dot product and cross products. After this video, you can still go back to that one. I'll drop the link in my bio so you can watch more and learn more. So for divergence, formula for divergence, D equals to your vector operator, very important. Vector operator is very, very important. Dot your vector function, which is v, like this. This is vector function they give us. It will not be v, it can be p, it can be a, anything. But the vector operator times dot the vector function. So divergence D equals to, what is the vector operator? Vector operator is I partial respect to x plus j partial respect to y plus k partial respect to z. This is a vector operator dot the vector function, which is x, y, I plus y, z, j plus 2 z, x, k. Dot products, don't forget. I've stopped this, posted a video. Now let's go again for dot products. So D now equals to I dot I 1 partial of this times partial of this, meaning we differentiate this xy with respect to x, but then partial of x times xy, meaning we differentiate this x with respect to only x. Differentiating only x here, differentiate x here to come to 1. What do we have left? Y. So y plus j dot j 1 partial of y times yz, meaning differentiate only y. So differentiating only y here, differentiate y here is turned to 1. What is left? Z. So we have z plus k dot k 1 partial of z times zx, meaning differentiate only z. Differentiate z here 1. What is the meaning? X. So x. So meaning our divergence is y plus z plus x. Okay, so this is our answer. Very easy. Those people that divergence is simply those products. As I said earlier, those products I've posted a video before and I'm showing it again. Those products is I dot I is 1, j dot j 1, k dot k 1. So we have our vector operator here, which is this. This is our vector. This formula for divergence is a vector operator times the vector given, which is v with this arrowhead. What is a vector operator? Don't forget, I partial respect to x, j respect to y, k. This is our vector operator times our vector, which is this x, y, I plus y, z, j plus z, x, k. Now, first find the dot product between these two, because that is divergence. Find the dot product. I dot I is 1. This is 1. Partial of x times xy. Just like you say, partial of x, xy. This means we differentiate the function with respect to x. Differentiating this function with respect to x, meaning you focus on only x. That's what partial means. When I took that derivation, that you focus on all of them. Partial meaning you focus on the one as in the denominator, which is x. So differentiating with respect to x, meaning you focus on only x. So differentiate x here, it will turn to 1. What do we have left? Y. But this is x squared. Differentiating this now, it's now become differentiate to x, only x, you have 2x. Y is still left. Y. That is how partial derivation is. Now what I'm going to do here is same thing for y, same thing for z. That we got this, and this is our final answer. Divergence is y plus z plus x. Now let's go back to the last question. So now the last one, which is chord. Chord is simply cross products. Don't forget divergence is what dot products. Chord is cross products. So every topic is linked to one another. Dot product and cross product now is linked to the position of vectors, which is divergence and chord. Now let's solve for this chord now. We have BV, our vector, which is V equals to x, y, I plus y, z, g plus z, x, k. This is our vector. And our vector operator, very important. I partial respect to x plus j partial respect to y plus k partial respect to z. As I said, chord is cross product. So let's see C equals to vector operator cross the vector itself. From the video previously I've solved, in solving for cross products, we use matrix form. Cross product is very, very difficult. If you calm down, then let's solve it together. So let's create a matrix. We have our matrix here. This is our matrix. We have I, J, we have K. So now, for our vector operator, the important I, J, and K, what is left? For I, we have partial respect to x. J, we have partial respect to y. K, we have partial respect to z. For our vector itself, the important I, what is left? We have x, y, y, z, and z, x. Calm down, slowly, slowly. We have this. Now let's find the cross product of this matrix. You can also go over. I do the video on cross products. You can also go over and learn more. So now let's go. Finding cross products. First, don't forget this: plus, minus, plus. Very important. We get our I. You eliminate the vertical and horizontal component of I. So if you eliminate here and eliminate here, what do you have left? You have eliminate here, eliminate here. You have partial respect to y, partial respect to z, yz, and zx for I. Next one, this plus, that minus. For j, you eliminate the vertical and horizontal component of j. So if you eliminate here, eliminate here. Eliminate here and here. What do we have? We have minus partial, it eliminates here and here. We have partial respect to x, x, y, partial respect to z, zx. J. Now plus K. Let me do this. For K, eliminate the vertical and horizontal component of K. So eliminate here and here. What do we have? We have this 4, which is partial respect to x, x, y, partial respect to y, and y, z, k. Okay? That's still solving. This key. Now, in cross product, don't forget, as I have 2 by 2 matrix, we find the determinant of this 2 by 2 matrix. So, we have I, find the determinants equals multiply and subtract. So, partial of y, this partial respect to y times zx, meaning differentiate this respect to y. And what zx, there is no y there. So meaning we have here as 0. Very easy, you have to calm down. Because products, partial respect to y times zx, there is no y here. So 0. minus. Now this times this. Partial with respect to z times yz. This differentiates with respect to z. So differentiating z, what do we have left? If we differentiate with respect to z, z become 1, we have y left. So we have here as y. Minus now for j. The same thing, cross products that you subtract. Let's start from here. Partial with respect to x times zx. When you differentiate only x, what do we have left? Z. So bracket z minus. Come to the other side, I've done this side, minus this times this. Partial with respect to z times xy. When you differentiate with respect to z, and if you watch this xy, we don't have z here, so we become what? 0. We have here 0. This is j plus. Now for k, which is here. Partial with respect to x times yz. Differentiate with respect to x. What do we have left? Y times yz. With respect to x, but there's no x here. So here is 0 minus. Partial with respect to y times xy. Differentiate with respect to y. So differentiate y here, 1. What do we have left? X. K. So this is I bracket minus y minus z bracket j plus minus x bracket k. So we have minus yi minus zj minus xk. The final answer. This is the curve of the vector. So don't forget, we put it in matrix form first, 3 by 3 matrix. You find the determinant. You eliminate vertical and horizontal component of each of them, I and j and k. We brought it down to this 2 by 2 matrix, following the row of plus, minus, plus, plus, invisible plus, minus, plus. Let me add it here. Plus, minus, plus. So here, you know that partial with respect to y times this. Meaning you differentiate this with respect to y, but there's no y here. It's this z, there's no y here, so it became 0. The same thing, minus this times this. There's no, okay, there's z, so differentiate z, 1, what's left, y? That is a y there. We did the same thing for here, and we got up to this place. We expand the bracket, 0 minus y, 0 minus 0, z, 0 minus x, minus x. We open this, and this is our final answer. Thank you. So please check up on the videos on dots and cross products. The link is in my bio so you can understand it better. Thank you.